Okay, so let's go ahead and we're going to start thinking about the different parts of this shape, kind of piece by piece, and we're going to think about the area formulas that we know for shapes that we're familiar with, and how we could use those formulas to help us solve this problem. So let's go ahead and start with what we see as kind of the front side of this shape, which is sort of, the part that's facing us, this big circular side, right? And so when I think about this, what I'm going to think about is that really this is a circle. It's a big circle that's got a smaller circle missing out of the middle, right? So if I could find the area of the big circle and then find the area of the small circle and subtract that small circle area away, right? Like if I could take this middle part away from the area of the big circle, then I would have, the part that I'm looking for, just the part that is the washer left over, right? So I'll find the big area. I'm going to take away the area that's in the middle there, and then I'll have, the washer part that's left. And then also, get rid of all this here. I also know that the front side of this washer and the side that's on the back that we can't see are exactly the same. So once I find this front area here, I'll just double it, and then I'll have the areas of both the front and the back, right? Okay, so let's think just for right now about finding the area of this entire big circle here that makes up kind of the outer part of the front side of the washer. Okay, so I'm going to find the area of the big circle, and we're going to think of this as the front of the washer. Okay, now I know how to find the area of a circle. The area, or the formula for area of a circle, is area equals pi r squared, right? And we know that we want to use 3.14 for pi. And so now what I need is the radius. I need to know the radius of this circle. So on the diagram, I have two measurements here. I'm given two different diameters. This stands for diameter equals 12 millimeters, and then I have diameter equals 22 millimeters. So the 12 millimeters is for the small circle, the hole that's cut out of the center. The bigger measurement would be the diameter of this entire circle going from one side to the other. So if the diameter of that big circle is 22 millimeters, then that means that the radius is going to be half of that, right? The radius is only halfway across, so it's going to be 11 millimeters. So I'm going to do, or plug that into my formula. And I'm going to find the area of that circle. And on the next slide, you are going to have a chance to calculate that and put that answer in to the lesson.